Okay, we're going to try to look at some things with degrees and radians again today. What we have here is a circle, and you can see this arc I have marked in red is being measured at 120 degrees. And you can tell that it's maybe about a third of the circle. In fact, it is exactly a third of the circle because if I try to go for what fraction of the circle that is, if I did 120 out of 360, that's going to be equal to 1/3 of the entire circle. So that is one way you can look at this, is that it's a third of a circle. Now, I might, instead of wanting a degree measure, might want this to be in a radian measure. So there's several ways you can convert from degrees to radians. One way is to find the fraction of how many degrees there are, like we did, and say it's 120 degrees out of 360, and then you can multiply by how many radians the entire circle would be 2 pi. So if it's 1/3 of the circle times 2 pi, I'm going to have 2 pi over 3 radians. So that is the amount of radians this is. It's 120 degrees, or it's 2 pi over 3. So that is an easy way to convert from degrees to radians. Now, sometimes in your book, if you see a formula, what they will have is they will have something like this, where it's the angle times the 2 pi over 360. And you can tell all they've done there, based on to create that formula, is they have just taken that fraction of the circle, the denominator from it, and slid it so that it went under the 2 pi. Doesn't matter really which form you use, you're going to get the same answer either way. So it's your angle measure times this. Now, sometimes also what you will see is, instead of having the 2 pi over 360, they might simplify it to just say it's the angle measure times pi over 180. The advantage to this is they've just reduced it, so the numbers you end up using are a little bit smaller. And basically, instead of thinking of all the way around the circle as being 2 pi, they're saying halfway around the circle is pi radians, or 180 degrees. So that is the way you are converting from degrees to radians. Let's do a couple more examples now that we've gone over where this formula comes from, and maybe that will help you to further your understanding. So let's change the amount of this angle a little bit. Let's say that we had a 70, well, let's go with a 90-degree angle, straight up a right angle. So if I have a 90-degree angle, what I generally do is I take the 90 degrees and compare, and then I know I'm going to be getting rid of the degrees, so I want to cancel out the degrees. So the whole circle is 360 degrees. That's why 360 is on the denominator, because I have 90 out of 360 of the circle. And then I'm going to multiply that by the number of radians in the circle, 2 pi. I usually just go ahead and think about the whole circle. And if I was doing this with a calculator, what I could do is I could just type in everything except the pi in the calculator. So I could type in 90 times 2 is 180 over 360, which would reduce to 1/2. And then I'm going to just add the pi into my answer. So my answer is 1 pi over 2, or 1/2 pi, however you want to think of it. That is the number of radians I would have there. Pi over 2, or 1/2 pi radians. Anytime you see a pi over 2, you can always remember you can put an understood 1 in front of it. And that's the same thing as 1 pi over 2, or 1/2 pi radians. It's the same thing whether you have the fraction in front with the pi beside it, or usually you'll see in the book they go ahead and put the pi on top of the fraction in the numerator there. Let's do one more going degrees to radians to be sure everybody has this. Let's make this one a little bit big. So let's go with maybe 100 and... Okay, it's measuring this angle at 150 degrees, but the angle measure of the arc is actually around on this side, which would be 210, because if I took the 150, the green arc, plus the 210, that would make 360. In fact, technically, if we were being picky, that 210, when we talked about coterminal angles, is the same as a coterminal angle of negative 150 degrees if I'm turning in the opposite direction. But anyway, once I know my angle is 210, I can take 210 and multiply it by 2 pi over 360. Once again, the reason 360 is on the bottom is I'm trying to cancel out my degrees, and they cancel out nicely. And then I have 210 times 2 is 420 over 360. And I could have done that in a calculator and just left the pi out and stuck it down on the paper for the answer. And when I reduce that, that's going to turn out to be 7 pi over 6, because I can divide both of those by 6, reducing me down to 7/6 pi. So that's how I get degrees to radians. Now, the other thing we need to know how to do is how to get from radians to degrees. Let's go ahead and do a couple of those. So let's say they tell you something is, let's go with 3 pi over 2 radians. It's a good idea to be able to estimate about how many radians that is. So remember, all the way around the circle is 2 pi, meaning halfway around is 1 pi. So straight up would be 1/2 pi, or pi over 2. And straight down halfway between 1 and 2 would be 3 pi over 2. At this point, it looks like my estimation has actually given me the answer, because straight down would be 3 pi over 2. So I'm expecting an answer 270 degrees. But let's go ahead and show you the formula in case we get one that doesn't estimate quite as easily. What I'm going to do is this time I want to cancel out the radians, so I put the radians on the bottom. So I'm going to put the 2 pi on the bottom, and I'm going to put the 360 on top. And what I'm going to do is I'm going to cancel out what I can. Now notice the pi cancels top and bottom. It's usually nice. A lot of times your radians will be in terms of pi. They don't have to be, but a lot of times they will be, and they cancel out nicely. And that leaves you with a 4 in your denominator. And 3 times 360 is going to be 1,080 in your numerator. So I have 1,080 over 4. And this, of course, the degrees did not cancel, so this is in degrees. 1,080 degrees divided by 4. Finishing your problem, I can divide by 4. Goes in 270 degrees, which is exactly what I was expecting. We'll do one more degrees to radians, and this one won't be quite as exact. We'll do this one in blue, though. Let's see. Let's try 11 pi over 6. Now, one thing I should notice is that 11 over 6 is pretty big, because 12 divided by 6 would be 2, so this is just smaller than 2. 11 over 6. It's definitely bigger than 3/2. It's bigger than 1.5. So if I was estimating this arc, I would estimate it probably as being all the way pretty close to the 2, something about like that. So to figure out what that angle is, I would expect an angle that's almost, but not quite 360 degrees. Definitely much bigger than 270, probably not quite all the way around the circle, so a little bit less than 360 to figure out it exactly. Remember, if whatever I'm canceling out goes in the denominator. So since I'm starting in radians, I need to cancel out radians, put radians in the denominator. Hopefully this is similar to what you might have talked about in some of your science classes. Put 360 in your numerator. Since that matches up, 2 pi radians is 360 degrees. I can cancel the pi's, and then I'm going to go ahead and reduce the 6 just because I can. So I have 11 times 60. Let's see, I could divide by 2 as well if I wanted to go ahead and reduce. So you could do all of this in the calculator, of course. Just type in 11 divided over 6 times 360 over 2, and you should get to the same place. And I think your answer is going to be 330 degrees, which matches up with our estimate that I would come up with something that was just less than 360. Hopefully this will help you. There's one other one I probably want to do just to help you with one that might seem a little bit more challenging. Sometimes you'll just have something that's just 2 radians and it will not have a pi. Even though this does not have a pi, since it does not have a degree symbol, it's in radians. So I still have to put the radians on the bottom, the 2 pi on the bottom, and the 360 on top. The difficulty with this is when I convert it, it's not going to come out pretty anymore. what I'm going to end up with this time is I would do 2 times 360 divided by 2, and that's going to just give me a 360. But since I did not put the pi in the calculator, I have to leave it on the paper. And since it's in the denominator, it gets left in the denominator. So your answer is 360 divided by pi degrees. You could, of course, put that in your calculator and get an approximate answer. It's going to be somewhere a little bit smaller than 120, but it's perfectly acceptable to leave it as an exact answer like that. Or if you wanted to see about how big it was, once again, type it in the calculator and it'll estimate it. Probably just smaller than 120. Hope these examples help. Feel free to reach out if you have any questions.